Hey, welcome to The Explainer. Today, we're going to flip the script on how you think about technology. We're going to take a journey from being just a user to starting to really think like a creator. Think about it. Use a computer, a phone, some kind of device every single day. But have you ever really stopped to wonder what's going on behind that screen? What's the actual magic that happens when you send an email or boot up your favorite game? Well, in this Explainer, we're going to pull that curtain back. We're going to shift from just passively using all this amazing tech to actually understanding the core ideas that make it all tick. It's kind of like learning the secret language of our digital world. Okay, first up, the magic box. Before we can even dream of creating with a computer, we've got to get a handle on what a computer actually is. Let's peek under the hood. Just look at this timeline for a second. It took thousands of years to go from a simple tool like the abacus to early mechanical computers. But then, look at that jump. The transistor in 47, the integrated circuit in 70, the first PC in 81, and boom, the smartphone in 2007. The speed of innovation just went into overdrive, taking computing from something that filled a room to something that fits right in the palm of your hand. It's incredible. At the end of the day, every computer breaks down into two main things: hardware and software. The easiest way to think about it is this. Hardware is the physical body, the processor, the screen, the keyboard, all the stuff you can actually touch. Software, that's the mind. It's the set of instructions that tells the body what to do. And here's an interesting thought. Your computer absolutely needs its operating system, like Windows, to even function, but it can work just fine without a specific app, like Word. And right at the very heart of all that hardware, you've got the CPU, the central processing unit. And calling it the brain of the computer isn't just a cute analogy. It's literally the electronic circuitry doing all the thinking, all the calculations, and all the heavy lifting that makes your programs actually run. So, we have this ridiculously powerful brain, which leads to the next big question, right? How do we talk to it? How do we give it instructions? Well, that's where we get into the language of logic. Before you can write even one line of code, you need a plan. And in the world of computer science, that plan is called an algorithm. The recipe analogy here is absolutely perfect. An algorithm is just a set of super exact, step-by-step instructions. It really shows you that programming isn't just about frantic typing. It's about thinking clearly and logically first. And this is the fundamental process that pretty much every programmer on the planet follows. First, you have to truly understand the problem you're trying to solve. Then you design your algorithm, your logical recipe. It's only then that you start coding, basically translating that recipe into a language the computer gets. And finally, you test it, find the mistakes or bugs, and you fix them. It's a really structured but also super creative cycle. And here is that translation process in action. As humans, we can say something casual like, if the number is even. We just get it. But a computer, it needs instructions with zero ambiguity, zero room for interpretation. The code on the right shows that level of precision. It strictly defines even as any number that, when divided by 2, has a remainder of exactly 0. Every single instruction has to be that precise. Okay, so we've got the physical hardware, and we have a way to give it these super logical instructions. Now, what happens when you combine these simple building blocks and scale them up, way up? Well, you get to create the mind-blowing technologies that are literally shaping our world today. And this is where it all leads. All of these incredible, game-changing technologies you hear about, artificial intelligence, robotics, the whole shebang, they aren't magic. Nope. They're all built on the very same fundamental ideas we've just been talking about. AI, when you get right down to it, is about creating unbelievably complex algorithms. The Internet of Things is just about putting simple hardware and specific software into everyday objects. It's all just logic, layered on top of more logic, built from the ground up. Let's just zoom in on one of those for a second, the Internet of Things, or IoT. This is basically the idea of extending the power of the internet and computing to, well, everything else. By putting tiny sensors and software into things like your watch or your thermostat, they can connect to the internet and create this intelligent web of physical devices that all talk to each other. There's a famous quote from a computer scientist named Edgar Dijkstra that just nails the whole point of this. He said, "Computer science is no more about computers than astronomy is about telescopes." And that's it, right? The computer is just the tool. The real discipline, the real art, is about something way deeper. It's about logic, it's about problem solving, and it's about figuring out how to manage massive, complex systems. So, once we start to grasp the immense power that these tools give us, there's one final and honestly crucial piece to this puzzle: our own role and our responsibility as we use them. See, every single time you go online, you leave a trace, like footprints in the sand. This trail of data is your digital footprint. And it's created from every website you visit, everything you search for, every message you send. Every single click is a part of it. And this footprint really has two sides to it. One is active, and the other is passive. Your active footprint is the stuff you knowingly share, like when you post a photo or send an email. But your passive footprint, that's the trail of data you leave behind without even thinking about it, like your computer's IP address getting logged on a website you visit. The big takeaway here is that this data is being collected whether you're intentionally sharing it or not. So, being a good digital citizen or a good netizen really just means acting with a bit of intention. It means being ethical and not stealing things that are copyrighted. It means being respectful of other people's privacy and their different points of view. It means being responsible and not engaging in things like cyberbullying. And maybe most importantly these days, it means being credible, thinking twice before you share unverified information. So, we're going to leave you with this final thought. Your digital footprint doesn't just wash away. For all intents and purposes, it's permanent. It's a story of who you are online being written every day. So the only real question left is, what story do you want it to tell?